Hey everybody. Thanks for coming to my talk, How to Build a Third-Person Camera System. My name is Jacob Grossman, and I'm a game programmer at Weta Workshop. Just FYI, I've got a link to GitHub to a demo project. When you see GIFs of a bear running around, that's the project that, that's what the project is from. Basically, what it is I'm trying to basically build a camera system which is better than what we had on Tales of the Shire. And so if you're at all interested to see the code and the math behind anything that I'm talking about today, you can check that out after. Overview, this is what we're going to talk about today. Why bother designing your own camera system? Defining parameters, constructing the camera location, modifying parameters at runtime, solving constant camera control, and a little bit on debug tools. So who am I? Hey, gameplay programmer on Tales of the Shire. Before that, I was a lead texture artist, 3D generalist, and did a little bit of illustration. There's to say, and I also didn't do math. As soon as I could stop taking math at high school, I did. So that's to say, if I can do it, you guys can too. Okay, so for us on Tales of the Shire, by the time we started asking ourselves if we wanted to go all in on our own solution or replace it with an off-the-shelf solution, I'd already spent quite a bit of time polishing the feel of what we had at the sort of like almost end of prototype level. And so after spending about a week testing an off-the-shelf solution, I just couldn't get the same level of control that we had over the feel of the gameplay camera. So we opted to keep working on our own system. So the TLDR is basically the reason why we rolled our own was for that high quality game feel. One thing I found while programming the camera for Tales of the Shire is that there is very little information out there about actually how to program this behavior. Hey, could I get the text a little smaller on screen just so I can see all of my notes? Sorry, I wrote way too many notes. Where am I up to? And also one of the things that I found while working on, while programming the camera was that there's next to nothing about the actual math that's involved online. And so that's one of the reasons why I wanted to do this talk. Absolute MVP, in order to define any camera point of view, what you're going to need is a position rotation. But obviously, we're wanting to build a third-person camera, so what we want is to be able to take some data, like avatar position, and pass it to the camera and relocate the camera to the desired position orientation. So what are those parameters we're going to need? First is the tracking point. This is probably going to be some pointed space, which is based off the root of your transform. Pitch. Next, that's obviously this is going to be the rotation on the local x-axis if you're using right-handed right-handed Z forward. So that's local rotation on the local x-axis. Next is that's going to be rotation around the world y-axis. Now, you absolutely could stop here if you have you absolutely could stop there if you have and you would have a very sort of bog standard student-looking level project. But let's say, hypothetically, a designer or art director came to you and says, hey, I'd love to have the camera sort of slightly offset on screen so that maybe they follow the rule of threes. Maybe they're up in the top left corner for some particular gameplay reason. Not only are you going to have to rewrite your camera location code, you're also going to have to rewrite your collision logic. And so I'm going to cover... sorry, it's my first big talk. You're also going to have to rewrite your collision handling code and correct any assumptions in your math that expects the avatar to be in the middle of the screen. So what we're going to do is we're going to handle this with variables, vector2 called framing. And basically what we're going to do is we're going to consider the center of the screen as being the 0, 0, with the top of the screen being +1 in the y-axis, and the left of the screen being -1 in the x-axis. Blah, blah, blah. Yep. Cool. And field of view, last thing. This is obviously something you can use to control the feel of your game for dramatic effect. So that all flattens down to a struct that we're going to call camera parameters. And this is what we're going to be editing at runtime to define our camera position rotation. But before we do that, we obviously need to take these variables and construct that position rotation. So that brings us to updating the camera location. So just FYI, there are many ways to do this. Oh, and also just FYI, I'm going to have my email at the end of the talk. So if you want me to just message you these slides, you're more than welcome. But all this talk is in, all of this code is in the demo project as well. So there are many ways of doing this. This is one way of calculating the location for the camera such that we get that offset. And so, yeah, going to walk through this line by line. So first thing you might notice is that we're outputting a location. That is just a struct that we used on Tales of the Shire to basically just package position rotation together. It had some like utility functions, which are pretty cool, just to be able to apply that position rotation to an object, a transform that you passed in. And so you could do that too if you wanted to. So the next is the half height. This is kind of complex, so I might get tongue-tied. But basically, what we're doing here is we're taking the field of view of the camera, we're converting it to radians and dividing it by half, and then getting the tangent of that. So what that does, that gives us a way of calculating how far we need to move the camera in order to place the tracking point at a particular point on the screen based on the distance. If that doesn't make sense, I've got this little illustration. So in order to support framing, we need to be able to figure out how far the camera needs to offset its local position in order to keep that tracking point in a particular location at different distances, right? So that's what we're doing. So we just calculated the half height, then we do the same. To calculate the half width, we just get the height and then multiply that by the aspect ratio of your rendering camera. That's important. Now we just construct the local offset. So basically this is, imagine we're like positioning our camera at the origin with our distance and our framing. So basically it literally is just distance multiplied by half width by our X framing value, and that's to get the X position, and then same with Y. And Z, because we're using Unity, Z forward, camera parameters distance is just like how far we're going to be from the tracking point. The next part, obviously, we're just flattening this down to final position rotation. So quaternion from Euler, showing pitch in the X, yaw and Y, and hey presto. Then in order to get the final camera position, we take the local offset, we rotate it, we multiply it by our quaternion that converts our local position and rotates it to be facing in the right direction, and then we subtract that from our tracking point. You might be like, why the hell are we subtracting? If you want an offset, don't you add something? But we subtract it because if you remember, like we are treating the top of our screen and screen space as being positive 1, and in order to put the tracking point at the top of the screen, we actually need to lower the camera, so that's why we subtract. And then we construct a location. And hey presto, there you go, you've got your camera location function. You can see like this is literally just a GIF of me editing the values at runtime, but with this is all you need to have, this is like a super solid base with which to build the rest of your camera system off of. So credit where credit is due. What I just walked you through is a slightly modified version I found on a blog post by Max Kaufman. So I've put a link to his blog at the bottom there. He has some great code examples, but he leaves a lot of lot to the imagination, interpretation. It's very pseudocode. So again, one of the reasons why I wanted to do this talk in the first place. Thanks. So the question now is, how do we go from the super minimal, almost like you literally can't control this at runtime yet. So I'm not going to cover input because literally that's going to be the same, as in like any game that you program is going to have ingestion of input. But from there, what we need to do is we need to update these camera parameters. So I'm going to step through it line by line. So on the left, you can see we're calculating the tracking point using a function called desired tracking point. And oh, my beautiful alignment. I made this in Google Slides. Okay, so the reason I'm sort of laboring this point is your code can be as readable as this. Again, we're calculating the tracking point. Literally, we're just in this function. We are just getting the avatar location, probably adding some configurable height offset and returning that. Next is pitch. I'm just going to fly over this as well. To calculate pitch, you'll likely want to take some input value from gamepad and mouse, multiply it by some camera sensitivity value, and then multiply that by delta time, and then add that to the camera's current pitch value. You probably want to clamp that to some like reasonable min-max, and that's to stop the camera flipping when you go over, say, like 90 degrees in pitch, go to like 91, then the rotation can like snap around, flip 180 degrees. So that's to avoid that kind of thing. I probably don't need to tell you guys all here to play all sorts of games in order to see what other games do with things like pitch. But I've got a couple of examples just because you don't have to just give your player full freedom. This is Yakuza 0, and you can see they're literally like clamping the pitch within, it's like roughly like 5 degrees and like -5 degrees, or like something like that. And you can see, so basically this is me controlling the camera, and what I'm doing is just holding up and then holding down and then letting go. And you can see the camera just automatically springs back to their desired pitch. So you can be opinionated about how you want players to view your game. Another really interesting example is Sword of the Sea, and in that game, the right thumbstick, when you're pressing up and down on the right thumbstick, you're not actually editing the pitch at all. What you're actually editing is the distance that the camera is above the ground. So you can see as I'm rotating the camera around, the camera is automatically orienting to look up or down at the character based on the kind of surfaces that the cameras above. Yeah, really, really cool. Next we'll do your. This is pretty bog standard as well, literally just what I said except for the bottom line, where I am wrapping the angle within the 0 to 360 degree range. And that's to sort of help keep our values sensible later on. And again, Yakuza 0 is super interesting. They don't like even let you rotate the camera past a specific angle if that angle is going to cause the avatar to be obscured in some way. So I just thought that was like really interesting. You know, like some games you play, the camera will punch in really close, but in this case, that is not even letting you rotate the camera at all. So yeah, it's totally worth checking out some games that have really opinionated camera systems to see what you can do. Okay, so distance. Got a couple of illustrations here. As you might remember, if you've seen the hit GDC talk, 50 game camera mistakes, it's a crime, apparently, to use the same distance for every viewing angle. Now, obviously, that's not an actual crime, but one side effect of doing that is when you rotate your camera down, your camera's going to hit the ground, and you know, as you're rotating down, before you hit the ground, you've got this nice arcing velocity, and then suddenly as you hit the ground, the camera's got nowhere to go but forwards towards the camera, and so you suddenly get this change in velocity, and you really feel that. And so I think it's totally worth doing what they suggest in that talk, which is changing the distance based on the pitch. So here you can see in this like little illustration, we can control that pitch. We can control the distance, make the distance a a function of the pitch, and that way we can like design this curve to be really nice. Something else you can do is, while we're talking about it, based on pitch, we can also do the field of view. If you increase the field of view when the camera is low, we can get a grander sense of the environment and take in more of the world that's around the character, rather than just like look up at your character's like model. So how do we program this? Animation curves. In Unity, we've got animation curves. In Unreal, we've got runtime curves. Yeah, this gives you the flexibility to control exactly how the value changes as your pitch changes. So here's the code for this. The most important part in this slide is the first line in the desired distance function, where we're passing in the pitch to the animation curve, and we're getting a value. And we're not just like passing that straight out as the desired distance, we're multiplying a designer set value that is the distance. So the reason why I sort of labor this point a little bit is that you could have your curve just totally just output the distance that you want and leave it at that. But that means like if you later on, if you've got like parts of your game where you want a shorter distance, and parts of your game, like let's say you're going like outdoors and you want like a way bigger distance outside, you're going to have to like construct another curve and blend between two curves while you're blending. And so my recommendation is to just make your pitch times distance curve just be a multiplier which applies over your desired distance. And also you can see on the last frame doing exponential decay, again like implemented as a the name's gone. Sorry? Oh no, it's like a, you know, it's like distance is a flow. It doesn't matter, I'll just skip over that. But yeah, I'm using exponential decay in this instance to smooth out that, that transition as well. Like any amount of decay that you add is gonna make these like scalar value changes over time just super silky smooth. And again, same with the field of view. And so here we go. You can see this is a GIF when the camera is looking straight down, the distance to the avatar is quite far, and when we rotate the camera down, the camera moves a bit closer. You can also see the field of view getting quite large when the camera is down low. I made it super large on purpose to keep it really easy to see. And I also just went ahead and changed the framing based on the pitch too. So you can see when the camera's sort of like down low, like normal game viewing angle, sort of like around 0 to 45 degrees. We've got the camera offset a little bit. And then when we're looking straight down, we can sort of slide that down back to 0. And that just means like, you know, like you can see everything that's around your player, around your avatar, sorry. And again, there's still plenty more that we could do based on this. Something that Nintendo does in Breath of the Wild is that when the camera gets really low, they increase the framing of the tracking point so that you're actually like looking up in the sky rather than looking up the nostrils of your avatar. Cool. So that brings us to the end of this like little section. What remains to get this behavior like specifically is basically smoothing out our camera movements over time. So adding more decay or interpolation using different interpolation methods, and potentially springs, because like you can see, I really don't like that when you rotate down and the camera just sort of like hits this, it's like we're rotating down, we've got, the camera has rotational velocity, and then suddenly we hit the minimum pitch or maximum pitch and the camera just can't move anymore. Yeah, there's lots of things you could do to ease that off so that either the camera slows down before we hit the minimum, or we could add a spring so that when you hit the minimum, we go past it a little bit, and then when we stop applying input, we sort of like spring back. Yeah, yeah, that's the slide. So the next part I'm going to talk about solving constant camera control. One of the more broadly applicable topics in the 50 game camera mistakes talk is forcing the player to constantly control the camera while playing this game. In Tales of the Shire, I address this with what I call your gravity in the code, but is exposed to the player as auto camera assist. The basic idea here is that after some duration of consistent movement, the camera starts to iterate its yaw so that it points in the direction that the avatar is moving. The reason I implemented this in Tales of the Shire is because the player doesn't really need to control the camera for any particular gameplay reason. Like, we don't have a bow which we need to shoot or anything like that. So the only real reason is to change the camera angle when you're going around tight corners. Yeah, and for the sake of time, I'm going to skip over what we implemented in Tales of Shire and just go straight to what I would do differently. And it's sort of how the solution that you see here is working. So breaking this down, the main things we need to know is, has the camera input expired? By that I mean the player has to have let go of the camera control for some period of time before we take control of the camera ourselves. If you don't, you sort of end up with this constant, battle with you as the player when you're playing the game. You're like trying to rotate the camera where you want it to go, but the game is like trying to point it, in a particular direction, and it doesn't always feel good. So it's difficult to see in this GIF exactly because of the way I edited it, but right at the very beginning, it's sort of not rotating, and then after the camera sort of like been moving for about a second, it starts to smooth in. The next thing we need to know is the raw movement input strong enough? And by raw movement input, I mean the input straight from the controller or the gamepad. And I like to do this because it means the camera will only start rotating if the player is intending to move at or close to full speed. What this does is it gives the player the ability to make small micro movements, like moving slowly or getting a position to take a screenshot of your game. And the final part is we need to know if the raw movement input is inside or outside a dead zone. This is obviously, you want this to be configurable so that you can edit it precisely for your game. But in this little illustration, you can see that the cameras are looking forwards. The green arrows are the raw input directions. And again, this is not in world space. The input hasn't yet been transformed to world space movement direction. This is purely in sort of screen space. So what happens if you don't do this is that you end up with this weird behavior where, let's say, for example, the player moves directly towards the camera and the camera already has some rotation offset, so it knows that it needs to rotate 180 degrees in order to get behind the player. But as soon as the camera starts moving, now that down on the gamepad means relative to the camera, that input has the character moving slightly sort of to the left of the camera. And so the camera, to take the shortest direction to get to 180 degrees of that rotation, is it's going to basically flip over the opposite direction. And so you get this crazy oscillation. Basically, the exact same kind of thing happens, but to a lesser degree when you're trying to move forwards, where basically you're holding forwards on your controller keyboard, and the camera's not quite looking forward, so it rotates to orient forwards, but now forwards in world space is slightly different, so the camera's got to move again, and you sort of, you get this oscillation. And an optional A dead zone is something that we added on Tales of the Shire, was a little dead zone which was like to cover the case where the player's moving 100% just like left or right, so adjacent to the camera direction. And the reason why for that is just because the game has a lot of chores, things like gardening, right, where you're potentially moving between two locations, maybe which are adjacent, so that you could move. Yeah, and basically I put that in so that the player could move immediately left and right on the keyboard, and the camera wouldn't automatically start rotating. So yeah, that one's sort of very keyboard specific, but it's an option. Oh shit, sorry, pushing the wrong button. So to sort of just cover all of that all over again, so things we need to know is, has the camera input expired? Is the raw movement input strong enough? And is the input outside of the dead zone? So this is very pseudocode, I apologize, but basically you can sort of get the gist. Basically, the only case I haven't covered that we haven't talked about is when the camera input has expired, but the player is no longer, the input isn't strong enough, right? And so in that case, this is a situation where the player has been moving and they have been strong enough and they haven't been controlling the camera, but then they let go. And so we have this Boolean, your gravity enabled. So basically that is controlling your spring. So I probably should have mentioned that first. So we're getting this rotation from a spring, which is designed to work in a 360-degree sort of range. And what your gravity enabled does is it's basically just telling the spring, hey, we don't want you to move towards the target angle anymore, and that smoothly decelerates the camera. Yeah, and if your camera input has not expired, then we're just piping out the current yaw anyway, so no need to do anything at all. So yeah. Final thing I wanted to talk about is debug tools. When you get to the point where you have got many, many, many variables which are retaining the state of some kind of manual smoothing that you've got, you want to have some kind of variable profiler like I've got here in this illustration. I built one for Tales of the Shire. I don't have one in my demo project yet, but it's absolutely necessary when you need it, because the camera, thank you, when the camera's moving, there could be any number of variables which are controlling its velocity, its position, its point on screen, et cetera, et cetera. And so you can see, I've got some in-world gizmos which are also describing the state of the camera settings. So, quick wrap up, what we've talked about, programming your own camera is totally doable, and the reason you do it is for high quality game feel, to have control over the way your game feels. We've defined the parameters that you need, we've constructed the camera location, we've modified parameters, and we have solved constant camera control. That's my email address. That's the GitHub link. If you have any questions, I think we've got maybe 1 minute. Does anyone have a question they want to yell out? Cool. Yeah, you've been a great audience. Thank you very much. Oh, find me after the talk. Yeah.